I'm Julie Johnson, and I won't have you all introduce yourselves, but thank you for coming, every one of you. And we have another, besides Josh Dumke, our presenter, we have 1, 2, 3, 4, 5, 6, 7 other folks on Zoom. So this is a great group of folks, or number of folks. This is our first in-person Zoom presentation ever to have both at one time. And this is our first in-person presentation since February of, or our first get together since February of 2020. So this is pretty exciting. So thank you everyone for coming out. Yeah, I'm glad. And let's see, couple people I'd like to introduce. Marco Sajan is our treasurer here. He's on the board. Peg Zahorik is in the kitchen. She's our recorder and on the board. I'm the secretary. And we've got some past board members here on Zoom and a couple, Leo and Corliss here. So thank you. And I'm really happy to see young people here. Thanks for coming. So, yes. Some echo? Oh, okay. We can switch to the other computer.
Is that better now?
Are you guys still hearing an echo?
Can you hear me? Is this Josh? I don't hear any echo. That actually sounded really clear to me.
Oh, huh. Well, I'm not sure what to think.
Well,
we got this one off.
Yeah, that one's off.
Yeah, there's only one mic on.
Okay, Chris Peterson says it's clear for her. So I guess we'll just carry on. Maybe. Oh, no, it's somebody's hearing. Dennis Khalid is hearing. Or somebody. Anyway, welcome to everyone. So as I said, I'm Julie Johnson. I'm the secretary for the Advocates for the Knife River Watershed. Oh, and one other special guest. We have Emma Ferguson here. You will hear about Emma. Emma is one of the researchers that worked on these projects. So, or this project. So first of all, I would just like to remind everybody or tell you outright, we are the Advocates for the Knife River Watershed, and we have been a group since 2011. And I just want to read our vision statement. And if you want a copy of this, there's some copies over there. But our vision statement is, we envision a collaborative community that strives to protect and sustain the health and stability of the watershed for present and future generations. Our mission statement is to be a citizen voice for the private and public land use decisions that affect the watershed ecosystem. Our goals and purpose are to conduct educational and outreach activities that increase public awareness of policies and practices that affect the Knife River watershed, such as tonight, to promote and engage in activities that can improve water quality in the Knife River watershed, to serve as a forum for citizen voices in private and public land use decisions that affect the watershed ecosystem, and to provide pertinent facts to agencies, elected officials, and the public regarding land use decisions that affect the ecosystem in the Knife River watershed. And our value statement is, AKRW values resource management practices which provide for and maintain diverse habitats and sustain diverse and resilient populations of native species of plants and animals. We are a nonprofit organization committed to learning about the river and promoting policies and practices that enhance the Knife River ecosystem. And protect the Knife River ecosystem. And we welcome new members. And if you haven't signed in, please sign in and we'll keep track of the folks that are on Zoom. And if you wish to be a member, there's membership papers over here, or you can go to our brand new website. It's AKRW.org, and you can sign up there to be a member and print off the membership slip and send it to our treasurer, Mark. So that's the advocates for the Knife River watershed. Any thoughts or questions about that? Okay. So tonight we have Dr. Karen Gran here to present research, and Josh Dumke up on the screen here. They are the two researchers that are here tonight to present the findings from the research study that we kind of helped get going. Yeah, and helped along the way. So several years ago, I don't remember exactly how we got started, but I remember sitting around the table with our other board members at the DNR Fisheries office, and talking about the fisheries management plan for the Knife River watershed, which includes quite a lot of beaver management, removing beaver and dams from the river, and asking, well, what do we need to, or are there things that we could study that would help us maybe refine the management plan? Is there a way that maybe we don't need to take out all of the beaver that we are taking out? So, and that's what this is all about, and Karen will explain in more detail. So this is Dr. Karen Gran. She is a professor in the Department of Earth and Environmental Sciences at UMD. Her research into rivers, sediment transport, and river evolution has taken her from Minnesota to the Philippines and back again. For the last 15 years, she has focused most of her research on post-glacial rivers in Minnesota, with applications for river management in the area. And I'll let her talk about the research, and the title is Effects of Beaver Dams on Low Flow Hydrology, Temperature, and Fish Movement in Minnesota Lake Superior Tributaries. And Josh Dumke is, as I said, with us, and he's the kind of the fish guy, and I will introduce him after Karen has a chance to chat.
We have a single talk that we're just going to keep running through. So go ahead and introduce Josh now, because that's
Okay.
belongs to him too.
Okay, all right. So Josh Dumke, who will also be presenting here, is a senior research scientist at the University of Minnesota Duluth Natural Resources Research Institute. And Josh's research interests include aquatic invasive species, fisheries, and how fish interact with their habitat. Josh has been working with trout and beaver interactions in Lake Superior tributaries for 15 years. So thank you to both of our presenters, and I'll let you begin.
Yeah. Make all the right adjustments here. Okay. Well, first of all, thank you all so much for coming. It's nice to give talks in person. I guess we're giving this one in full-blown hybrid mode because we've got Josh online, we've got viewers online, and then we have viewers here as well. So as Julie said, I'm Karen Gran, and then Josh Dumke is going to be giving the second half of the presentation. But I also want to start off by acknowledging all of the people who worked very hard on this presentation, one of whom is in this room, who worked for the research. So Sally Diamond and Rebecca Teasley, who were co-investigators on the project, Emma Bergeson, Hannah Behar, and Nick Peterson, who are graduate students who worked on this project. Most of the work that I'm going to be talking about is work that Emma and Hannah did for their master's thesis. See if we can make this go away. Go away. Nope. The fun of Zoom. I can't make the bar go away. Nothing important is at the bottom of the slides. And then also Alex Nazaro and Sarah Mitchell, who are at the College of the Holy Cross in Worcester, Massachusetts. And this was a pandemic exercise, and we had data sets that needed analyzing, and Sarah had a student, Alex, an undergrad out at Holy Cross, who needed data sets to analyze because they couldn't do field work and they couldn't get in the lab. So they analyzed some of the temperature data as well. And then I also want to acknowledge Sea Grant, who funded this research. So many thanks to Minnesota Sea Grant. Now, all right. So I think everyone here is probably aware that beavers are ecosystem engineers. They fundamentally alter habitat from stream to pond. They open up the canopy, which can have changes to the solar radiation. They can create longitudinal barriers for fish, for trees, for sediment, for water. And they can also fundamentally change the hydrology of the system. They raise the water table, they can redirect the flow, and they can change timing of those flows as well. So there's a lot of things that beavers do to their ecosystems. We got involved in this project, as Julie said, because this is where I say a local citizens group was concerned, because the advocates of the Knife River watershed were concerned that the management practice that involves removing a lot of the beaver dams might be having detrimental impacts on the flows in the watershed. And so, yeah, you invited me to come and give a talk about the hydrology and the knife. And I remember I wrote back and said, well, I could talk about the geomorphology and the knife. I haven't really worked on the hydrology. But we got to talking after the talk and they said, you know, what we really care about, right? You know, what we really are concerned about is the hydrology. And we're worried that removing all of these ponds might be negatively impacting it. The Knife River watershed is home to the large majority of the spawning habitat for rainbow trout along the North Shore. And thus it is managed pretty heavily to remove those beaver dams in many cases to allow those spawning fish to get upstream. And so the concern here is that if removing those dams is actually having negative impacts on the hydrology, then a practice that is meant to help one species might actually be harming the species it's intended to help. So we were brought in to see if we could figure out what happens to the hydrology, and particularly low flow hydrology. So we weren't interested in the peak flows. We were looking at the low flows. How is that impacted when beaver dams are removed? So what do beaver dams do? Well, we know that they can impact the low flow hydrology. They're storing water upstream in the watershed and they're slowly releasing it downstream. We also know that they can impact the temperature, right? As you change from stream to pond, you can heat up the surface of that water, but they're also changing flow pathways and that impacts the temperature as well. And we know that beaver dams can impact fish movement as well. And so the concern was if the act of removing beaver dams actually raised the low flow hydrology, cooled temperatures down and improved fish movement, then removing them makes sense if fish management, in particular rainbow trout management, is your top priority. But if in fact removing those dams causes low flows to drop even lower or causes temperatures to go up, then, and maybe they don't have a huge impact on fish movement, then this management practice might actually be harming the species it's intended to help. So we were brought in to try and figure out how does beaver dam removal impact fish management, fish movement, and low flow discharge. We added in temperature data later. That actually wasn't part of the original study, but we had access to a handful, like 50 temperature sensors from the Natural Resources Research Institute. So we deployed those in and around our study sites as well. So I'm going to start with this figure that Hannah put together to talk about how water and temperature move through a system that has a beaver pond in it. So let's talk a little bit about hydrology and heat fluxes. So start with the hydrology fluxes. So when you impound a pond like this, a number of things happen. First of all, you increase the amount of surface area that is exposed to the atmosphere. That can increase evaporation rates, and so that can cause a loss of water to the system. In addition, however, you're raising the water table, which can cause an increase in storage in the system. You also can increase the hydraulic head, which causes an increase in the flux of water downstream. So you could actually be raising the water levels downstream. And you can also have water that's, being held back by the dam that isn't making it downstream, and that could decrease the flows downstream. So some of these cause an increase in flows downstream, and some of them cause a decrease in flows downstream, which is one of the reasons why we wanted to study it, right? The trying to predict this ahead of time is complicated, and it's not clear. Not everything points in the same direction. All right, who's got the car alarm? We'll figure that out. Okay, they figured it out. So similarly, if you're looking at how beaver impoundments impact temperature, it also could have both warming and cooling effects. So again, if we have this large impoundment, it increases evaporation. Well, that actually cools the surface of the water through evaporative flux. However, we're also have this big body of water exposed to solar radiation, and that would warm the surface of the pond. So one of those is a warming effect, one of those is a cooling effect. If you have water that's moving from the pond downstream and it's coming off of the surface of that pond and trickling over the dam, you might be warming the waters downstream. But if that water is moving through the subsurface and upwelling downstream from the dam, it could be cooling the waters downstream. So again, it's not obvious up front how the Beaver Dam is going to impact temperature. So again, this is the kind of thing that makes for a really good study. We don't actually know the answer going into it. So hydrology could be positive or negative, temperature could be positive or negative as well. And so that's why this study was put together. So I'm going to talk a little bit about how the study was set up using Emma's figure here. So the study was a classic Bakke design, which means before after control impact. We had 4 paired watersheds in the Knife River, 2 sets in each geomorphic regime. Let me walk through what I mean by that. In the upper watershed here, see, we've cut off the words here that note all the good figures come from the graduate students. So I just want to acknowledge that, right? It's cut off for the screen here. But so the top 3 photos come from the upper watershed. This is an area that we like to think of as up and over the hill. So it's you have deeper depth to bedrock, you have so deeper soils, more storage, kind of a hummocky landscape up there. When you move into the area that's the dark blue, the lower watershed, that's what the 3 lower photos are from, that you have a much shallower depth to bedrock. There's a lot more clay. That's area that was covered by Glacial Lake Duluth. So there's lacustrine clays at the surface. And in some cases, the river is actually on bedrock. So there's less storage down there. So we set up 2 pairs in each of those geomorphic regimes. All of the streams that we were looking at were small headwater streams. All of the basins had active beavers and active beaver dams in 2018 when we started this study. In 2019 then, so they're set up as paired watersheds. In 2019, half of the pairs had beavers removed and dams notched. So each of those sites had one control site where the beavers remained for both years and a treatment site where the beavers were removed. The low flow hydrology and temperature could then be compared before and after the dam removal on both the impact and the control watersheds. We also did a fish movement mark and recapture study on both the Knife and the French rivers that Josh is going to talk about in a few minutes. So there were a number of methods at each of these small watersheds. The sites were instrumented. The downstream-most beaver pond was instrumented. We also tracked the amount of flow coming out of the watershed. And we tried measuring evaporation and precipitation as well. That didn't work as well just because we weren't able to get out there often enough. It rained a lot that first year. And then we also collected water samples to look at stable isotopes of hydrogen and oxygen that can tell you something about flow pathways, so where that water has been. And I'm not going to talk about the stable isotope data at all, but if you're interested, Emma's here, so you can ask her questions, or you can contact Sally Diamond, her other advisor who knows about the isotopes more. So let me walk through some of the measurements that were made. So looking at low flow discharge. So we wanted to know how much water was coming out. So all of the streams were instrumented with pressure transducers. So it actually measures pressure and pressure changes. You can correct that for atmospheric pressure changes and measure level. So we were essentially measuring water level every 15 minutes. Now, in order to turn that into discharge, the actual flux of water coming out of the watershed, you have to convert level into discharge. And that involves measurements. So there's Emma out measuring discharge. So actually measuring the flow at different levels and developing a rating curve, which is what's showing down in the corner there. I wish we could make this go away, but maybe we'll stick it up. I don't know, it was gone earlier. All right, well, so we have stage height on the x-axis, we have discharge on the y-axis, and you can see, make a series of measurements, and then you can develop a rating curve that you apply back to your level curve, and now you have discharge coming out. What we were really interested in is how much time did the river spend below a low flow threshold, so at low flow conditions. And one of the challenges that we learned early on is that studying low flow is really hard. There's not really a set threshold that defines low flow. And you're only going to get one measurement each year, which is the number of days or the amount of time that the river spends below that low flow threshold, which is different than studying peak flows, where every time the flow goes up, you have a peak flow measurement that you can grab and compare. So we looked at a number of different low flow thresholds. And the first one was base flow as recorded after 3 weeks of no rain. So that was declared to be low flow, and then we could look at the amount of time the river spent below that. We also looked at 2 different measures of the 75th percentile flow. So this is the DNR's definition of low flow. But we couldn't just use the 75th percentile flow means the flow is higher than that 75% of the time and lower than that 25% of the time. We couldn't use our records alone because we're sort of setting it a priori that it would be at low flow 25% of the time. So we used the Knife River gauge, which has been running for several decades, to define a 75th percentile threshold, and then we scaled it to our small watersheds. And we scaled it in one case by area and one case by discharge. And this is all Emma's work here. And then we put together a composite threshold that combined those different thresholds, and I'm not going to talk about that either, but I'll show you the results from the other 3. So before I show you the results, I want to talk about how the BACI design works and why we use it. So the idea is that in year 1, you can go out with your paired basin, your treatment and your control, and you can look at, in this case, how many days that watershed spent below low flow. So let's say they each spent 30 days. So they're basically behaving the same in year 1. In year 2, we remove the beavers and we measure it again. And so in this hypothetical example, the control had 60 days at low flow in year 2, and the treatment had 90 days. And so what's not important is that they both went up. What's important is how they behaved relative to each other. So in the first year, it was a 1-to-1 ratio between them. And in the second year, it's now 1.5 to 1. So the treatment had more time at low flow relative to the control. And that we can attribute to the treatment itself. So we had 4 paired basins. So essentially we have 4 data points, 4 replicates that we could use to see how the treatment impacted the time spent at low flow. All right, we do have to move this so you can see down here. Okay, so we have, we would plot up then our control watershed variable relative to our treatment watershed variable. So in this example, we plot, say, number of days at low flow from the control relative to the treatment in the first year. And then we do the same thing in the second year. And so what we're curious to see is, does that slope change? Because if we see a change in slope, in this case, the slope increased, it means that for the treatment spent more time at low flow in year 2 relative to the control in this example. And so if we were assessing the impact of beaver dams on low flow, and these are the results that we saw, we would be able to say, okay, well, our data shows that by removing those dams, the rivers are spending more time at low flow. So we've decreased the flows. Does that make sense? This is a little complicated, but this is important for how we set it up. Now, one thing you'll notice, we had 4 paired watersheds, but I've only put 3 data points up here because life just doesn't always work out perfectly. One of our gauges blew out in the flood in early of 2018. And although we found it and we reinstalled it, we didn't get enough data to get a good rating curve. So we ended up with 3 of the watersheds that worked well and 1 that we unfortunately had to pull because we didn't have enough data for one of the variables in 2018. So these are the results from those. We'll move this out of the way down here. Okay. So what you're looking at are 3 different thresholds. So we have the area weighted, the tributary to main stem threshold, and then our precipitation free one is down here at the bottom. And again, we are interested in how these slopes changed over from the first year, which is the lighter color, the light gray is 2018 and the black is 2019. So we're curious in how those slopes changed. You might notice they change differently in every single threshold. But you also might notice, those of you who are squinting going, is that really a regression line? Yeah, like not all of these relationships are very good, right? We have 3 relationships that are pretty strong. We have R squared's 0.97, 0.99. And then we have 3 that are just crap, right? So you can't really say anything about the slope of that line because the line doesn't, the data are just kind of, they're not really fit. So in the end, we actually only had 1 of these 3 thresholds that gave us statistically significant data to fit those 2 regressions and actually a statistically significant slope between the 2 years. And that's the precipitation free threshold down here at the bottom. And so that one shows an increase in the slope from 2018 to 2019. So that would indicate that the streams were spending more time at low flow after removing those beaver dams. But I also want to, this is where you throw out lots of caveats, like it's messy, right? And what threshold you use matters, and it could change the results. So this is why the composite threshold was one attempt to try and put these all together. We're still working on the statistical significance of that. So I'm going to move on to talk a little bit about temperature. So again, we installed temperature sensors sort of above, within, and below the impoundments at all of our sites. We measured average daily air and stream temperatures in July and August, so the 2 warmest months of the year, and tallied up the cumulative hours that were spent in stressful or lethal conditions. And then could compare again, control versus treatment in 2018 versus 2019. So this is data that was worked up by Alex Nazaro. So here are some of her results. This is a ratio of the treatment site to the control site. So if we look at 2018 here, we can see that all of these numbers except for one are greater than 1. That means the treatment sites started off warmer than the control sites. That's important, again, only as it compares to 2019. When we look at 2019, you can see that all of the numbers went up except the one at site 4 here. And so the numbers increasing means that the temperatures increased downstream from the treatment sites relative to the control after those dams were removed. So removing the dams in this case at 3 of the 4 sites warmed the temperatures downstream relative to the controls. The other way that we addressed temperature was through a study by Hannah Behar. So she worked on her master's thesis out here as well. And she was really interested in actually modeling heat flux. So she instrumented the heck out of 2 of our watersheds, site 2 and site 4, and installed temperature sensors in arrays. So this is an array of temperature sensors. So you could get the temperature like at the surface and then 5 centimeters down, 15 centimeters down, et cetera. So you could actually see what the temperature gradient was. And that allows you to look at for upwelling and downwelling, among other things. So Hannah had a weather station out there so she could track solar radiation and wind speed. She measured the temperature in the ponds, in the groundwater, in the stream going downstream quite a ways, and then put together a model of heat flux. So she could understand not just what the temperature was downstream, but how, like what was driving it. So these are some of her data. I'm just going to show the data from site 2. So this is a picture of site 2 here. Here's the Beaver pond. And the pond is located at this arrow. So what you're looking at on the x-axis, on the x-axis is distance downstream. So downstream to your right and upstream to your left. The black is the average temperature, and these were for a couple of weeks in July. And then the minimum temperature was blue and the maximum was in orange. And so one of the things that you can see here is as you go downstream from the dam, things cooled down pretty substantially. And the minimum temperature actually stayed cool all the way more than 300 meters downstream. The mean temperature recovered some, but it still remained cooler than it was above the pond. So there's in this particular case, like the temperatures were really cool. Hannah actually had a hard time getting them that cool with her model. And what looked like was happening is that the groundwater, in this case, the pond level remains very high, and water is seeping through the subsurface and coming up, sort of upwelling into the stream downstream of the pond. And it's cool water that's coming into the stream. And like Hannah had it modeled like just coming in from the bottom. It wasn't enough. We had to have it seeping in from the sides. She had to keep track of the fact that there was actually tall grass there. There were no trees in that area downstream because the beavers had removed them. But the tall grass was enough to shade this little channel. And it was really cool in more ways than one. The other data, I'm going to move this bar again so we can get to it. These are groundwater level data, and this is also from this site. So again, in this case, the site we're looking at here to the treatments, this is the control site, 2B. So that's the dark black here, and then the gray is the treatment site. And these show that relative to each other, the groundwater was much higher in the control site in the second year relative to the treatment site. So the treatment site, the groundwater table dropped more, which makes sense because the pond disappeared. All right, so I'm going to summarize the temperature and low flow data, and then I'm going to hand this over to Josh to talk about fish movement. So first of all, yeah, beaver dam removal can potentially impact low flows and temperatures. All right. So here's what we found, that for the flows, removing the beaver dams increased the time that was spent at low flow using that one statistically significant low flow threshold, which was the base flow after no rain. The results do depend in part on the threshold that's chosen, right? It's pretty complex. We did also see that groundwater levels in the upper watershed dropped at treatment sites relative to the control sites after dam removal. So it was a measurable change in the groundwater levels. That was not as clear at the sites downstream, the ones that had the shallower depth to bedrock. And then for the temperature, temperatures in 3 out of the 4 pairs increased after dam removal. And the ponds that feed those downstream waters via subsurface flow were found to have a pretty significant cooling effect on the river downstream. And this is where I usually put up big caveats, like this is a really short-term study, right? Ideally, our Backy study would be like 5 or 10 years before the dams are removed, 5 or 10 years after the dams are removed. Our low flow data, we get like 1 data point per year. And so we don't have a lot of our N is small, as they would say. But I think the data that we see don't support the idea that you would want to remove beaver dams to increase low flow or cool the temperatures down, right? So I think there needs to be, they support a more nuanced approach to beaver dam removal. And I also think that in at least one case, this site U2, which is also called 2B, we changed our nomenclature halfway through, was a classic example of an upland beaver pond system with elevated groundwater and cooler water downstream of the dam. So in that case, I think it was pretty clear that it was having a cooling impact downstream, storing the water upstream, is increasing those low flows, it's keeping the groundwater table high. And that's all good for fish. I'm going to pass this off, and I think the way to do that is to stop sharing and let Josh share, and we'll do questions at, well, you go ahead, yeah.
Well, I'm
Go ahead.
wondering if it would be helpful for the audience to know what the names of those creeks are, if you remember. It might make it more meaningful.
Yeah, Stanley was 2B.
Mhm.
It was just down the road from there, from Julian Rod's house. Emma's got it.
A lot of them are unnamed. We had one up on Old Drummond. The Drummond Grave, like way up. 3 was at the end of Shilhan. So kind of in like a bigger channel, the bedrocky area. And then 4 was nexted in there. So also in that kind of same area. And then one of our 3 sites was off of Hawk Hill Road, kind of at that where the bridge is. And then upstream.
Kind of drive to the end of Hawk Hill Road and then hike to the west of it. Yeah. Yeah.
Thank you.
Yeah.
If you
Thanks.
have more questions later, I can.
Yeah. Quick question?
One thing.
Yeah.
Right now, the National River Month.
Ah,
The other thing is, if you look at the results and the conclusions, the United Kingdom has gone back to beaver. They haven't had beavers for 500, 600 years. They're going back to it. And some of the things you're saying right now, they said, we got to clean our river up and the beaver will part of that program. Have you read anything?
I'm not familiar with the UK specifically, but I have seen a number of studies from Europe where the numbers of beaver were pretty decimated and they're working on bringing them back. They're also actively trying to get beavers back out in the Western US, and they use them frequently for stream restoration and to raise the water table. We could talk about this more after Josh.
Okay. So we had it paired the water part of the project with including some species of concern. So we were focusing mostly on steelhead in the beginning. But when we were doing some lit review on fish passage around beaver dams and what other people had done, there was one paper that kind of caught my eye, Kemp et al. From 2012, which had multiple parts to it. Some was a lit review, some was surveys, but they had cited that 78% of citations stating beaver dams were fish barriers were speculative, and there wasn't data actually showing whether or not fish were being stopped by beaver dams or not. It was the conclusion drawn by an author without the supportive data. And that was mirrored in the survey of fisheries managers, angling groups. I think they had included Department of Transportation people, anybody who had anything to do with beaver removal or worked with beaver as part of their jobs. And that same assumption was kind of there, that beaver dams were barriers to fish, but a lot of those were ideas or opinions. And there was very few occurrences of data actually showing the interaction of beavers and fish. So we had figured this is something that would be great to get data on. You know, why even guess? If we were all standing on the bank looking at this beaver dam, talking about whether that's going to stop fish or not, you know, what's the point? We should get data on that. And data generated in this project may inform future decision-making in Northeast Minnesota, but also other regions around the Great Lakes with similar lake run trout and beaver interactions. And that's really what gets the most attention, is the trout and salmon that live in Lake Superior or other of the Great Lakes traveling up tributaries to spawn. That seems to be what sparks the most attention in these interactions, and whether or not fish are being stopped in their upstream migrations to reproduce. Data will get folks with different opinions, maybe some common ground for discussion, and we'll see if that happens or not. So the plan was to survey around the project beaver dams selected for the hydrology and hydraulics research portion, and look for the presence of young of the year steelhead. Because if we found young of the year steelhead upstream of a dam, we would know the adults had to have gotten up there. The young of the year, when we capture them in July, are about 1.5 inches or 1.25 inches long. They're pretty small. They're not great swimmers. They basically are hiding out in the slack water areas along the edge of the shoreline in the rivers. And so they're not really expected to be traveling upstream great distances. So if the young of the year were found above a dam, then we could infer the adults got above a dam. So that was the plan, going around beaver dams before and after the pairs that were removed were taken out, and see if we found any differences in where we found young of the year steelhead. Well, in reality, that wasn't going to work out. So there were a few beaver dams located in the Knife River main stem due to dam removals and just local trapping effort. But there were probably 3 or 4 spots in the river where we found young of the year steelhead at all around the tributaries that were selected for the project. So in 2018, we did some electrofishing around project dams. On the map, the project dam approximate locations are the white lines. The circles are the summarized findings of fish surveys. So we surveyed directly above and below dams. And if we found no water or no fish, that's a red circle. A orange circle is fish, but it's mostly a population of minnows and no trout are present. Blue is minnows and some trout are present, but not young of the year rainbows. And green circles are where we found young of the year rainbows. And you can see there's only 2 dots on this map. We did do a few other surveys in some other places, but we didn't include those because they weren't around the project site. So the point is, the project dams were high up in the headwater tributaries, generally in places that trout and especially migratory steelhead were not occupying. So we had to pivot. In 2019, we expanded the scope to include dams in the Knife and the nearby French River, and include all species encountered. So we were still prioritizing the research in areas that had trout, but we were open to including other things like suckers and creek chubs and black-nosed dace and other fish living in stream reaches. And the other thing that we had to do was just work around low head dams or smaller dams. We couldn't have sampled these very large ponds because the water was just too deep behind the impounded or the edge of the dam. The impounded water was usually 2.5, 3 feet deep or more, but then you would have about 18 inches of soft silt bottom or clay, and it was just too hard to wade around, and we couldn't sample in those. So we had to work in the smaller dams, the ones that were about 3 feet high or less. So what we did is we found beaver dams and grouped them as active dams, where we had 4 that were active dams or inactive. And there were 4 of those. Inactive dams were simply ones that beavers had abandoned and were no longer maintaining. But they were still creating some kind of a hydrologic control. So they were still holding water to some point. And paired control stations were created to evaluate normal movement of fish. And we had 4 control stations. And this photo is an example of what a control looked like. There were reaches above and below a riffle. And the riffle was the what we normally would have had in place of a beaver dam. So instead of a dam, there's a riffle. It's not a barrier. It is just a grade control, and it's separating 2 reaches that we marked fish in differently. So we were hoping that by having these control stations, we would be able to establish how much movement fish are doing without a barrier in place. So there's an example of the Knife River study area, just to kind of show how these areas were set up. We had some places on the Knife River and some on the French River. This image is about a stream distance of 750 meters. It's a tributary of the Knife, not managed for beaver and considered marginal trout water. The study reaches consisted of paired controls, which are the green squiggles down near the bottom, separated by a riffle, and upstream multiple stations that had orange. Those are the stations that we surveyed are the orange squiggles, and the red dots are the dams. So around the dams, we had stations above and below, so we could mark fish and determine if they moved beyond a certain dam. Fish were collected using backpack electrofishing units. We tagged the fish in August and recaptured them in September. And that was a span of about 4 to 7 weeks between mark and recapture. Fish movement past dams or control were determined by mark and recapture. So we knew where we marked fish in one place, we recaptured that same fish in a different area. It has a mark that doesn't correspond to that reach it was found in. You know, it moved. Marks used were what's called a visible implant elastomer. It's a mixture of a color and a hardener. It's injected into the fish by hand with a syringe, and it hardens to a rubber-like consistency. Fish more than 60 millimeters were anesthetized so they wouldn't be flopping around. They were tagged with VIE, monitored for recovery, and released to the midpoint within the reach they were collected. When we were doing our collections, in total, we captured and tagged 395 trout, all tagged in the postocular space or the dorsal fin membrane. The postocular space is kind of a fleshy pad behind the back edge of the eye. It's a good place for marking trout. And the non-trout, which are mostly minnows, especially black-nosed dace, we marked over 800 of those. They were tagged in the cheek, the gill cover, or the dorsal fin membrane. And the arrows are showing tag locations in several different example fishes. A subset of VIE tagged fish also received partial pelvic fin clip to determine rates of VIE tag loss. So this is a new method for marking fish for my group. Several other papers had published how well these tags are retained in different fish species and different body locations, and it was uncertain what I would experience. So I wanted to do a subset of these fish that also had a pelvic fin clip. So if I recaptured a fish with a partial pelvic fin clip and no VIE tag, I could start to determine rates of tag loss. And that does become important later in analysis. So at the dam locations, I monitor the dams and the water level with time-lapse photography. So there's a camera on a stake that was set to take a photo every hour. And there's a staff gauge out in the pond, which had lines every 20 centimeters. So every hour I could see how the water depth changed in the pond and how water was interacting with the dam. When I went to the dams during the fish surveys, we would stop and measure things about the dam, like how long it was, the width, the height, and water depths on the downstream and upstream side of the dam. For data analysis, we tested for differences in fish movement among dam classes, such as whether they were active or inactive, and whether or not they were large or small, and against movement among control reaches. We used proportional movement, which calculates percent movement based on fish recaptured, and that can handle differential tag losses and capture efficiencies because it's based on what you recapture, not the entire sample of fish that you originally tagged. And I looked for correlation of fish movement to covariates of time between mark and recapture, how much rain or cumulative precipitation there was between mark and recapture, and what the flow conditions were like at the dams between mark and recapture events. And that was determined through time-lapse images. So in summary of the fish recapture, of the 1,200 fish tagged, we recaptured about 21%. We did a little bit better on the trout. We got 30% of those back than we did the minnows. 90% of recaptured fish did not move from the reach they were originally tagged in. There was no movement difference between trout and non-trout. We were really interested in the 10% of fish documented as moving over the study period. But keep in mind the sample size, 10% of 248 is about 25 fish. So 25 fish moved over the mark recapture period. There were no significant differences among dam classes of active or inactive, or whether dams were big or small compared to controls. But this is based on a sample size of 4 in each of these groups. There's 4 active dams, 4 controls, 4 inactive, and only about 25 fish even moved. So there's a lot of variability. Differences would have had to be very large to actually make any significant determination here. So the point is that their data were kind of overlapping among all groups. Maybe there was a little more fish movement in the smaller dams than the larger dams, but the point is there wasn't a whole lot we could really tell because of sample size issues. A small sample size makes some of these nuanced differences quite hard to detect. So we looked at correlations. The time between mark and recapture survey had a significant positive correlation to fish upstream movement. But this is likely a red herring because there were some other factors at play here. The data were collected at different times among the two systems. We started in the French River, then there was about 8 or 9 days of significant rainfall. We couldn't work in any streams. We came back when the flow conditions were starting to subside, and we sampled Knife River. So these are two different systems sampled at 2 different times after substantial rain event. So I didn't want to run anything off of just time that a fish has to, bang its head against a barrier. If it's a barrier on day 1, why would it not be a barrier on day 45? So we looked at other things that are controlling fish and their ability to interact with dams, such as precipitation. Well, the problem is there is no significant correlation with fish movement and precipitation because the regional cumulative or max rainfall is measured at too broad of a scale. French and Knife River are not very far apart, and there wasn't anything that could really separate what these two watersheds were experiencing on a finite enough time scale. Plus, the mark and recapture are static endpoints. You mark fish at one time, a whole lot of time goes in between, you recapture them, and we don't know anything about the movement, the daily movement that might correlate with daily precipitation. So it didn't really matter that much that precipitation events occurred. We could not measure how fish were reacting to that. But flow conditions at dams was something that I thought maybe if I looked at time-lapse photos, I could see how each dam behaved around precipitation events and see when they experienced substantial overtopping flows, because every dam is different. And that's the challenging thing about doing any work with beavers, is every dam is different. They make different decisions, they do different things, especially when there's rain events, every dam changes. So that's the other question here, is designating what a substantial overtopping flow is. So the next 3 or 4 slides are examples of what overtopping flow conditions I used to say this is an overtopping flow. So here's an example of 2 dams that are 20 meters apart. These are Knife River. They are not very big. I think the Knife River Dam 1 is, at most 3 feet high. The Knife River Dam 2, you can look and see how much water is actually held back there. It's probably 14 inches tall, 12 inches maybe. But the Knife River Dam 2 is just upstream of Knife Dam 1, and you can almost even see it. If one tag alder was cut down, you would probably see the second dam. So I'm going to show what happens over the course of a 3 or 5 day period of rainfall and how these 2 dams changed. Right now, they're given a big red no, meaning there are no substantial overtopping events right now. Okay. We go to the next day, we got some rain overnight. So the upstream dam, Knife River Dam 2, is experiencing substantial overtopping flow. Water flowed over. It also flipped to an inactive status because overnight, and I had about 95 pictures showing 2 beavers working busy for 6 hours straight, they built up Knife River Dam 1. They raised the water level on that dam about 20 centimeters, flooded out the dam upstream, and abandoned it. So that dam, Knife River Dam 2, is flipped to an inactive status and is experiencing substantial overtopping flows. Go forward again. We got about 1.5 or 2 inches, something like that, over about a day period. So now Knife River Dam 1 is experiencing substantial overtopping flows. Knife River Dam 2 is completely submerged. So this is what I was doing when I was going through the time-lapse images, finding how much time each dam spent in this substantial overtopping flow condition. And the other thing to notice with these high flow events is look at Knife River Dam 1 and notice how the downstream water level has risen. Well, that's because upstream is a pond. There's a lot more area for that water to spread out. And downstream, it's confined more to a channel. So as the water flows increase, the 2 ends of the dam, or the 2 water levels above and below, get closer and closer together. And it becomes less of a tall stick-like barrier and more of an overflowing continuous water riffle. So when I transform the data into time spent at overtopping flows, fish passage was better explained. So each dam experiences different conditions during all these different rain events. Water arrives at them different times, beavers behave differently at each one, and different dams are taller or whatever. However they experience that precipitation event can be captured with time-lapse images, which is showing a function of precipitation and dam characteristics. And this image is, or this figure is leaving out the controls because they had no time when they were assumed to be a barrier. They were always experiencing overtopping flow conditions. They never dried up. So this is just showing the dams only and fish passage at these dams with the days at substantial overtopping flow on the x-axis. So more time spent with overtopping flows, there was more fish movement up and downstream around that dam. So we found brook trout, rainbow trout, juveniles, and seminal species past dams upstream. There were 11 individuals moving upriver, and downstream there were 7 fish that moved downstream. But recapture rates were relatively low at 21%. And the question remained, what happened to all those fish? So this was a image I wanted to insert just to show an example of a minnow that passed this dam. This was on the French River, and you can see what it looked like in conditions without overtopping flows and in conditions with overtopping flows. And so it looks much different on whether you would assume a fish could pass it on low flow or high flow conditions. I just inserted a story about a fish, and there's another one. Natural mortality and high flows at recapture is one of the things that could be limiting our recapture rates, right? These are a lot of small minnows, and there were a lot of fish-eating birds that camped on every dam, blue hens, American bitterns, kingfishers. There was probably some mortality from fish-eating birds at these places. Also, when we were doing our recapture surveys, high flows reduced our efficiency to recapture fish. So I had mentioned when we did our recapture, we came in after some high flow events, and I showed you some images of those on the prior slides. When you go in during high flows, the water is more turbid, you can't see as well, you're dealing with more discharge, so there's more area for the fish to move around in and for you to have to cover. And if it's rainwater, like we were dealing with after these precipitation events, it actually has less conductance. So your equipment is shocking less well. And so our efficiency was about 15% less in our recapture surveys than during our marking surveys. But the other thing that we speculate is fish may have been leaving the study area completely. And that's supported by two things. One is when we did our recapture survey, it's not like the fish were gone. We were finding quite a few fish. And in fact, most of the time we had the same number or near the same number of fish in the recapture survey as when we marked them, just not many fish with marks. So if they were leaving the study area completely, it's speculated that other fish must have been moving in, and there was a lot more movement going on than we were even capable of measuring. So one thing that supports this is this site on the Knife River, where in the map, there's a star and a dotted line and another star. So this creek chub was marked down in a control reach. It swam upstream 600 meters and passed the dam that I'm showing as two images, one in low flow and one in high flow conditions. So this creek chub passed that barrier, which may not have been much of a barrier during high flow. And it was recaptured upstream at the base of a dam in an upstream reach. So we know that fish were moving at least what we measured up to 600 meters and skipping big areas of stream that we didn't have survey stations located in. So fish could have been moving around a lot more than we were even measuring. The other issue was tag loss. I had mentioned before that that became something that I was thinking about and had a way to try and measure how much tag loss we got. In the minnows and other non-trout, we had greater tag loss. 32% of those tags were lost in our recapture survey. It was better in trout. Only 10% of trout lost their tags, but the trout are a little bit fleshier. They've got some fat on their body, and they're not as lean as these minnows. So the non-trout tag loss was different by location. So in the cheek was the best, although I do show an image here of a tag loss in a creek chub that was in the cheek. So that was one of the few individuals that had lost his tag from the cheek mark location. The dorsal fin was 50-50, but the gill cover was 83% loss. And that was really too bad because it was the easiest spot to mark these minnows. You could slide the needle right under the skin. It would slide right along the bone of the operculum, and you could inject the tag, and I would, touch it with my finger, and it felt like it was going to stay, but apparently the skin was just too thin there, and a lot of those tags were lost. So tag loss in the minnows was definitely an issue. So there are some conclusions now that he had completed, the fish movement part of the study. We found that both trout and non-trout fishes passed less than 1 meter tall dams up and downstream, though not many of them. There was no significant movement differences among dams and controls, but again, it's a pretty low sample size. Only 25 fish moved in total. And dam passage correlated to duration. Each dam was overtopped during high flows. So each dam became passable at different flows. And the impacts of these findings are limited by small sample sizes and just looking at small dams, because we don't know if at, say, a 4-foot high dam or a 5-foot high dam that correlation of overtopping flows and fish movement falls apart. There may be a threshold there in dam size that we did not include. And it was excluded adult steelhead. There is no way for us to include adult steelhead as the focal species of this project, but that could be addressed with a larger research project in collaboration with DNR and local advocacy groups to tag adult steelhead with pit tags, which is longer term in a multi-year study. So there are some ideas about how we could find out ways to work with adult steelhead. It would just be challenging, but there are ways to do it. And I think, Karen, this is where you wrap things up for everybody. Not sure how your audio is on.
Okay. Yeah, so I'll just say a few quick words because we had a tricky transition in there. Mostly just a reminder to everyone that our study was intended to look at how beaver dam removal impacted low flow and temperature, and how the presence of those dams impacted fish movement in the Knife River as well as part of the French. But what it doesn't tell you is whether or not you should remove beaver dams, right? That's a decision that has a whole lot of more components to it. There's a lot of species that benefit from having pond habitat. There's species that benefit from having stream habitat, and that moves into sort of a societal decision about what to do with the data. But our goal is that our data do provide some additional information that people can think about when they're making those decisions. And my hope, at least, is that it leads to perhaps a more nuanced approach to beaver management in watersheds like the Knife, where we do have some of these upstream ponds in particular that clearly are storing water, providing water to downstream, providing cool water to downstream. The site, the 2B site, the one on Stanley Creek that I mentioned, like everything was just nice in terms of supporting fish downstream with that dam intact. We went out to visit it, that was last year, right? 2021, and the dam had been notched. And so instead of, the beavers were frantically fixing it. So it's probably fine now, but what happened was it took a system that was holding water and sending cold water through the subsurface and upwelling downstream into a system where warm water was now pouring over the top of that dam, which is exactly what you don't want in terms of temperature downstream. So that's kind of a case where knowing a little bit more about the system that you're working in could lead to better management. And Josh, if you could go to the next slide, I think it's just the final one because we're still looking at your slides. Well, the final one is thanking everyone who worked on this project. Hey, there we go. So again, Minnesota Sea Grant, who funded this project, Desiree Hendrickson from DNR Duluth Area Fisheries assisted, and the DNR was in charge of all of the beaver dam notching and the beaver removal. The advocates for the Knife River watershed who got us interested in this in the first place and who helped out extensively with site selection, made muffins for the field crew, rescued students who got lost, everything. A whole host of field crew. These are the ones who were out there for whole summers or large chunks of them. So Craig, Lizzie, Heidi, Emily, and Laura, and then also the NRI field crew who do the fish work. And with that, we can take questions. And Josh is still there too. So.
Yeah, you might have to repeat the questions for me.
The optimum range and temperature for the steel.
Yeah, so the question is, what is the optimal range of temperature for steelhead? I'm going to see if Josh can answer that one. I'd have to go back and look it up.
Oh boy, off the top of my head, I cannot remember. We've got charts for that.
Okay, can you turn yours off?
Okay, and you just want to talk about.
Yeah, okay. Okay. Not. Hang on.
If you mute.
I know I have to get back to this.
There we go. Okay. Like I gotta go find Zoom. I was gonna look up the slide that actually has these. So these are data for rainbow trout from Moro and Fishneck, and the optimum temperature is less than 18 degrees Celsius. Once you get above that, you're into acceptable, up to 22 degrees Celsius, and then you're in stressful and lethal. One thing that I didn't mention when I was showing this one earlier, the amount of time that these ponds or these streams and ponds spent at stressful and lethal temperatures, so our study sites, was pretty high. So as Josh noted, they're not trout waters, but they're upstream from trout waters. And so it's important that we send water that is as cold as possible downstream, even if the water that is there wasn't stressful. Yeah, others?
What do you think has changed when there were, the creeks were plentiful? What do you think has changed? The beaver were here then. The beaver have been here for 68,000 years.
Great. That's a big question. What's changed? You look around it. So yeah, land use is obviously different. The climate is changing. Things are warming. So that's also changing. The distribution is changing.
Started before the farming.
Yeah, the warming trends have been going, yeah, the strong ones have been in the last decade. So, but I mean, land use has changed in this area as well. And beaver management came in. I don't know. I'm going to switch back over to looking at not ARC, Zoom, to see if Josh is there. Josh, do you know more about the history of the beaver management? I can't remember when it started. It used to be more extensive on more North Shore streams. And then they kind of consolidated down to just the ones without barriers on. You might be muted.
Oh, well, sorry.
No, there we go.
Okay. Well, no, I'm not an expert on the history of beaver management, but there was things going on in the end of the 18th century, well, the 19th century, when the whole area was logged over. At that point, beaver had been trapped out prior to that logging era. There's a lot of change that we seem to have noticed around the 40s and 50s when the landscape was repopulating with trees, beavers were coming back. And that seemed to be about the time that a lot of these non-native salmonids were introduced. So during that time, there was a lot of change going on. Landscape was starting to change. The species were changing. Public interest in different species was changing. It's hard to say exactly, you know. I don't have a lot of the history that I've done the research on myself. I know that there was a lot going on in the 60s, 70s about finding beaver control measures that were going to promote the salmonid fishery. So a lot of it was going on at that time.
Other questions? Yeah.
Were there any circumstances where temperature continued to decrease as you got further downstream, or was the beaver pond temperature generally your baseline low?
I don't recall ones that continued to decrease downstream. It was more we were kind of looking at how far downstream did that cold temperature persist if it was colder downstream. There was one dam that Hannah had worked on that actually was a chain of dams, so there were two in a row, and it looked like there was sort of downwelling going in one and maybe upwelling in the next one. So the temperature was not, one of them it was colder than the downstream of the dam, the other was warmer downstream of the dam. But that one had some more complex flow patterns. But yeah, I don't think things continue to cool.
So during,
Spring's coming in.
during like summer times when the upstream waters are, you'd be inferred the cold water.
Yeah, well, you could get, I mean, you could get different temperatures if you had differences in shading. So the areas that we were looking at, a couple hundred meters downstream, was sort of the, for the most part, the beaver impacted areas. You'd eventually get into the we had some of the gauges were downstream enough there. So. Emma's welcome to chime in. Yeah.
Yeah, each downstream area was a little bit different in terms of like how open it was, whether it's going through like, you know, power cuts or forested areas. So I don't know. I didn't do the verify as much, but definitely as you move downstream and get to the, larger streams, there's more surface area, more opportunity for surface water to running in.
I guess the other thing is that this is true for a lot of the North Shore streams, that it's not like you have temperature flowing in at a certain degree and then it kind of stays like that everywhere. You get refugia. So you have places where you have small, seeps coming in, springs coming in, maybe a deep pool that allows some of that water to seep in. And those are the places that cold water species can hide, essentially, when conditions aren't good elsewhere. So it's not, we're probably never going to get the whole watershed cool enough, especially not the way the climate is going. But preserving and saving those cold water refugia is really important, because those are critical. So I guess maybe one way to think about it is these beaver ponds help create, in some places, cold water refugia, both at the bottom of the pond, in addition to downstream.
Which I don't think gets enough credit. The bottom of the pond, I mean, you were in the pond every day, collecting samples. I mean, not that my feet are good, like, it's 20 degrees, it wasn't warm. There was a clear stratification between the top and bottom in a lot of these bigger ponds. That was pretty deep, and I think it's just something to consider.
Yeah.
When you say, when a lot of people say beaver ponds create warm water, that's crap. You have to look at the stratification and how much changes, and whether the bottom, which connects to refuge, if that actually is depth cover.
Did you, only work on a little bit?
No, think so.
Okay, I was trying to think.
Because I
think
referred
3 and
everything by
4
the street and number. Yeah,
I think the 3 and 4 might be part of the whole life.
you can put the map back up too. I can put the map back up for the people in the room and share it for the people in the, but it's a small map.
Where's the confluence of Little Lake?
Pardon?
Where's the confluence of the main stuff?
The expressway.
Okay, then probably, then I think 3 and 4.
It crosses Homestead, mile up road to.
Yeah, because
Sorry, we don't have the best map to, we don't have the names of the streets. There was another question in the back though. Or not. We got the family now, but yeah.
I wanted to add, and have you, I wanted to update the group and have Karen add information too, and there's others there. So a year ago, Karen had mentioned this, a year ago, in June of 2021, yeah, we, the board invited about 15 agency folks, including Desiree Hendrickson, the fisheries manager, to an outdoor meeting. And so we met, and Karen presented research, and Emma was there and presented research, and Josh was there and presented research. And we had a really pretty good discussion with Desiree and the other agency folks. And we walked out to the 2B site. Yep, on the Stanley. Yeah, on the Stanley. And I don't know if you want to say anything about the conversation there, but then I wanted to ask Josh a question.
Oh, well, I mean, I kind of mentioned this at the end, was that the dam had been knocked, and I was kind of shocked. Like, this one, we should not have done it too. What we don't know is who knocked it, whether, because the DNR doesn't do all of the, as you well aware, not just the DNR that's knocking with the dam, tracking beavers, but there are various, fishing groups that enjoy that as well. So it's not clear who did it, but that was a case where I was surprised. And I don't think Desiree expected it up there either. So,
And
yeah,
I guess one of the things that surprised me when we saw that was that the stream was like a foot or two wide.
yeah,
It was tiny. It was really tiny. And so we had this discussion, and one of the things that came up in the discussion that Desiree mentioned a couple times, please, was that there is no DNR money to count fish. And that the night, no, this is where.
this is a question for Josh, he might know more
Yeah.
about this.
Yeah, Josh maybe remembers, but that the DNR used to have a rotation where they would count fish in the knife, and the knife is like some number of years past the year where they would normally count fish. And that it sounds like there is no money to do that. So I guess my question for Josh is, what does Josh know about that? I remember more details about that. And it seems that that's a big deal. I mean, if we're managing for fish, but we don't know what fish are there, how do we base this management?
In my case, on the little knife, they came every year. They could drive down my field, and get in there and do all the stocking. And after about 4 or 5 years, in the early 90s, they never came. I asked for right. And I ran into one of the guys downtown. And I asked him, there are no trout in the river. We for 2 years. Well, we quit.
Yeah, Emma. So I think partially to answer that question, I'm fairly certain that every steelhead that comes up from the lake has to go to the trap. So those are counted. But then from there, I don't know that they do count either coming down.
They
I
used
think
to
they try
count
to,
the one
it's
plus.
really not either.
They used to just the one pluses there.
Oh, up or down.
Dropping out.
Yeah. But sometimes I think it's just higher, so it's too much that year. But they do try to do that. So they're counting, they're just not tracking where they're going afterwards, and that's more on the people watching the watershed.
So I guess my question for Josh is, what, you mentioned, Josh, that there's research that could be done. It would take more years and more money and more time to accurately assess the fish. I wonder if you could comment on what that research might look like.
Sure. Well, as far as when the fish have been counted, I mean, you can go online and look for Knife River fish reports. I don't know when the most recent ones were, but they usually give numbers of adults and smolts for a season. And it's been a while since I've even pulled one of those up. So I don't know if they stopped, in 2019 or something and haven't produced those reports for a while or not. But yes, they do have mechanisms for capturing the adults. And when I mentioned a study that could use adults, I had been talking with Nick Peterson and having some idea brainstorming events about if we were encountering adult steelhead, could we work with those and tag them and use them as part of a study? The issue that we might run into more so than working with the fish is working with a dam that's left in place in a place that steelhead will encounter it. And that's probably one of the issues that would have to be ironed out well in advance. Another issue with an alternative, so the French River has been stocked with steelhead for several years with tens of thousands of steelhead. They put them in an area that they know has a lot of beaver. It's not managed for beaver because of the falls. No steelhead or lake run fish can get into the river. So they've just left the beaver there. And there's quite a few dams in the French. And one of the ideas was, well, what if we captured adult steelhead that are returning to the French, can't get very far, probably eventually bail out and go back out in the lake and go somewhere else. But they are, it's possible to seine them. And so you could encounter adult steelhead in the French, tag them and move them upriver of the barrier and have them interact with beaver dams as they intended to travel upstream. Well, the issue with that is moving fish above a barrier is they have to pass certain disease checks. They can't have bacterial kidney disease or VHS, so they have to be screened for those before you can move them above a barrier. So there's some issues with the logistics of just what kind of barrier we would want or allow these adult fish to encounter. The third option is there are what they have called out west beaver dam surrogates. Basically, they are just low head dams made by man. So back in the CCC era of stream structures being put in, some of the structures were actually low head dams, and they were logs laid in the stream, some logs pinning them to the bank. And the point was to create a low head dam, and it would serve the exact purpose of a small beaver dam. It would retain water. The only difference is you would have to figure out where you could put some of these structures if that was the intention, and they would have to probably be removable after a certain amount of time with the study. So that's something that there are options to work out the details on. It could be something that works out, or it might just never get traction and never happen, to be honest. But there are ways that we could work with the adult fish. It's just what kind of barrier is going to be in place for them to encounter and measure how they interact with it.
Question?
Yeah, so not directly, but you said a while ago about how when you show so is there maybe is there people that I'm sure people are watching without research and making sure that not
Yeah. So
other people do it because they have their
yeah, so I'll just rephrase your question, restate for people online. So the question is whether people are notching dams. Are they keeping track of whether those are like good dams? Do they have data of these ones that want notch, et cetera? As far as I know, no. The DNR manages the main stem rivers and not the tributaries coming in. So they have some geographic limitations on what they actually manage. They have an area that they would manage and they would use the dams out there. I don't know if anyone here is in the steelheaders group, or so I know there's a number of fishing groups that are maybe not beaver friendly and have a tendency to remove dams where they find them. So there's and then there's also landowners who will remove dams because they're impeding, their dam is flooding on a road, or they're causing property damage or whatever. There's a number of different reasons that the dams are removed. There's a season that it has to happen. You can't just go, so you can't trap beavers year round. I guess you could rip out the dams whenever you want. But yeah. So as far as I know, no, there isn't really. I mean, we don't have a survey of which dams we should keep in place and which ones we should remove. And I think people would probably differ in opinions on which, yeah, whether or not they should be there. So yeah.
So that's why I think that really be helpful.
Yeah.
To let people and
Yeah. Well, Josh, I don't know if you mentioned this earlier. This is the third or fourth talk that we've been on this. So we were at the Arrowhead Fly Fishers group 2 weeks ago, and the Isaac Walton League a month or two ago, and part of that is just to spread the word. So this is what our data have shown. that some of these dams, if you love fish, you should probably use them in place, because they're serving other ecosystems that are beneficial.
One thing I wanted to update the group on is that when we did have this outdoor meeting in June with the agencies and Karen and Josh doing the research and Emma, and 2 months later in August, the advocates for the Niagara Watershed Board did get a phone call from Desiree saying, Desiree Hendrickson, the fisheries man, saying that they made a decision that they were going to stop managing for beaver on 4 of the small streams, one of them being the Stanley, and because in some years the stand is just one dry without the beaver pond. And I cannot remember, maybe someone can hear what the other 3 streams are that they are no longer going to manage. So I felt, or we felt like that we made a difference in engaging researchers to look at the data about beaver. Really, are they damaging or are they helpful? And so it's made a difference to get together and talk about it. So thank you, and thank you, Josh.
Thank you.
Yeah. Oh, yeah. It made I was talking this is that. So no, that's good.
As researchers, you always hope someone's listening.
Yeah.
Yeah.
So yeah. Are there other questions?
Is there any more research planned?
Not with our group on this project right now, although I know Josh has been trying to get funding for a larger study. I don't know the status of that, for the fish movement. I'm still learning comments on it.
Yeah, the challenge is finding an appropriate funder and making sure that this is all screened well ahead of time on whether or not there are enough groups in agreement to allow it to work. So that's the challenge that I have to navigate, is finding out what is the proposed testable question. What are we testing the movement of steelhead past, and how many dams do we need, and how are we going to do it? So that has to be aired out with several groups ahead of time.
Yeah. I will say that when we were approached by the advocates, do we know the answer to this question of what removing the beaver dams does to the hydrology? One of the first things I did was go talk to the DNR, because if they already knew the answer or thought they already knew the answer, there was really no point in us like proceeding forward with the study. And they said, no, we don't know. We don't know. We don't have data on that yet. We need that data yet. And so I think getting people who will value the data is really important. Otherwise, you never know if it's going to be used. So it's actually really good to hear that the DNR thinks.
Yeah, yeah. And of course, Josh, if the advocates for the Niagara Watershed can help, please let us know.
Yeah.
Do you know if prior to beaver management, anybody ever did a baseline water count in any of these streams to find out?
Yeah, I do not know the answer, but wouldn't that be nice? Yeah. Josh, do you know about baseline temperature studies before beaver management on the stream?
So my experience with so I worked at a Superior office, and I was tasked with being a fisheries technician and taking beaver dams and tag holders out of trout streams, and that was what my thesis was on. And in those systems in the Bayfield Peninsula, where it was all sand, the conditions were very different than I've experienced here on the North Shore. A lot of the beaver dams would actually fill in very quickly with sediment that was mobilized, and they would create these long sand flats. So when I came into the office, that was basically my exposure to beavers are bad. You know, we pull out the dams, we trap out the beavers because they're stopping fish and the ponds are filling in, and it's nothing good is happening. So prior to me arriving in an office setting like that, where that was the ingrained setting for 30 years, probably, I don't know what the original biologists, you know, in the 40s, 50s, 60s, how they looked at this interaction between fish and beaver and what they used to make their determination to, label all beavers as bad for lake run fish. If it was all based on fish movement, or if they included any actual data on stream temperatures or habitat or survival of young of the year fish during drought conditions, I have no idea what some of these early biologists saw. And I really wish that we had more information like that. But we know that we were limited in making decisions based on data, and a lot of it was based on opinion. And so at least getting some data is giving us a place to start with.
Yeah,
I have one more question, and I may have missed it, but what years did you do this study?
this study was done in 2018 and 2019. So data analysis was ongoing in 2020.
I know last summer was pretty much a drought summer up here.
Mhm. Yeah, no, we weren't working out here then.
Beaver Dam, out of the Jug Road, that had, I don't know, 8 to a dozen adult steelhead trapped up,
Mhm.
and someone like reached.
I was,
It's like, I can.
Carol always wants to be political. I am, but I'm not so much. In some of these regions, there was no water in the stream except for the dam.
Yeah.
And so that there's a balance. Sure, maybe it's a little warm, but if there's no water, then, that's a deep part.
I know when they talk about coasters, reestablishing coasters, there's not the groundwater springs that they need for barrier in order to successfully spawn.
Mhm.
And I've often wondered, when you have primeval forest, that you've got how many feet of black forest dust built up. It sucks the water up till it comes to an impermeable barrier, and it will seep into these watersheds as cold water. But when you have extensive fires and slashing, how much of that got burned up right down in the soil or rock?
Mhm.
What kind of effects did you see on keeping them discharged and control? Was there any kind of stabilization effect?
So we didn't actually look at the peak data. It's on our list of, we have it, we should go and look at it, but no, we haven't analyzed that. Yeah.
Other questions?
Yeah.
I grew up on the nice 60s, 70s, most of the 80s. That's before the beaver controlled the DNR started really getting hot and heavy. We had steelhead, we had brook trout, we had beaver. On the nice, you'd see steelheads up on the Drummond line, on the Rossini, not many. Some did make it up. So there should be a balance.
Yeah.
And what I think, not wanting to pick on the DNR, but I think these trout groups probably have a real lot of influence on the DNR's decisions on this beaver control. We should strike, or not we, they should strike a balance.
Mhm.
We know how much they, steelhead, that million troops they got 3 years back to their genocide.
That might be what this comment is about. Lizard Sam has funded beaver removal. I'd like to see it fund more research on it.
I
You're all
don't think that the
citizens.
Lizard Dam actually funded any beaver removal.
They funded a lot of restoration. work.
Restoration by the LSA also does, or is in favor, has members that are in favor of beaver removal, but the actual money was not used for that. It was used for restoration, stabilizing things, creating fun habitat.
When going to say that not on the DNR, it's safe to say that they don't have that.
I mean, just to be fair, like the DNR does have data as well. They have some places where they've got data above and below dams that shows more movement. And so it's not, but that could be a very different system. Hopefully you've seen like dams are different. And if you have a run of the river dam that has the warm water pouring over the top on a regular basis, that might be different than some of these far upstream. But again, I think it comes back to the nuanced management. Recognizing that not all of and some of them are actually beneficial.
Is there research that we could support that would give some more answers for a more nuanced management approach?
I mean, I think I feel like we just scraped the surface. This was such a short-term study. I mean, one of the challenges is grants come in 2 to 3 year blocks. They don't come in 10-year chunks, hardly at all. You know, the agencies, so they have the ability to make that a priority and put that into their own funding. From our perspective, it's a lot harder to do that. And I also think it was actually really challenging working in the night because the dams have been removed. So we ended up pushed way up into the upper watershed to find dams intact. And so, you know, Josh pointed out working on the French, there might be a lot more potential there because there are dams there that have been there for a long time, and that maybe this study might be better ported to a place that wasn't as heavily managed. Yeah, you'd have to
be applied to the next year.
Yeah, all up and down the shore. I mean, I think, and it's also worth pointing out, there's a lot of research on beavers and dams and hydrology in other parts of the country that I often hear people say, well, it's different here. Well, yes and no, right? You know, it's not that different. So we can also take advantage of some of the research that's been done in the mountainous areas out west, where they have noted that they put beaver dams in for restoration to raise the water table to detect channels for floodplain. A lot of things that people do here, not with beaver dams at the moment. So there is other research to be drawn from. I think having local data makes a bigger impact on it. Yeah.
Have we collaborated with there's been collaboration?
Not that I'm aware of. There have been a few studies where people have tried to integrate, you know, lots of other studies. So there's a paper that came out very recently by Sean Dunk's site that was reviewing sort of Midwestern beaver studies. So that's kind of a larger reach. Josh mentioned that study in his first slide of looking at, you know, when people were actually assessing all the different situations where people had published stuff saying beavers block fishing. Most of it was not backed up by data. I'm not aware of like a nationwide survey or study, but it might exist. I'm just not aware of it.
Or have collaborated with
yeah, and now we're stretching even further away from the funding challenges.
Probably different climate environment.
Well, I think the UK has the beaver were essentially eradicated, and now they're bringing them back. And same with much of Europe. Like the beavers were basically removed from those areas, and now they're trying to bring them back.
They're also slightly different species.
Yeah, it's not the North
The
American
base beavers, it is essentially a reverse treatment from a removal to an introduction.
Yeah, so I feel like we kind of live in beaver heaven here. I mean, that's what I was thinking as I paddle around the boundary waters. I'm like, if I was a beaver, I would want to live. So we have a lot of beavers, and other people. Yeah, sometimes you talk to people from other areas and they find out that we are like removing the beavers from fish. They're putting the beavers in fish. Right. So there's some funny juxtapositions. I was in Nebraska once and they were like removing trees for habitat, you know, restoration, and other places they're putting trees in for habitat restoration. So it's like different places are doing different things. But the beavers, yeah, like we're one of the only places with this region that is like actively removing fish that I'm aware of.
For non-native.
Thank you.
I have a practical question. As a landowner who has a beaver and build a dam, an area where we couldn't it was causing damage, and it was encroaching on the road. Are you aware, maybe this is too practical, but are you aware of ways that we could encourage beaver to build dams in certain places and discourage them in others? Because the DNR came in and just discouraged the couldn't be low power. So,
That's right. Yeah, you also aren't allowed to trap beaver removal.
right.
So, yeah. What?
Beaver dam and a lot.
They do put, yeah,
Also
BDA.
devices you can put to control the water level.
Yeah, so you can stick it in so it flows.
It's also like your tub, like
Yeah.
you have the drain, so it doesn't.
There's a brochure, there was a brochure about that.
I will look at it.
Yeah.
And then, the Sean Johnson bike, research was brought up, and that research is available if you go to AKRW.org. That is posted on our website. You can read that research. An extensive study.
Mhm. Yeah.
I watched a show on nature, and I believe it was filmed in Concord National Park. Back,
Mhm.
and not wanting to trap beaver in the park, they had a gentleman that was more or less a beaver whisperer. And he made tape recordings of running water. And beaver
Yeah.
can't stand the sound of running water. And he could get them to build dams where there was no reason to even build a dam.
We had one try to build the dam, or try to get into the engineering building on campus.
Yeah, yeah, there's a beaver dam on campus, and the beavers tried to get into the building.
Basically, right now in northeastern Minnesota, beaver are pretty much out of control. MnDOT spends tens of thousands of dollars every year
Mhm.
just trying to keep us safe driving down these roads. I've seen it where you got 4 inches of water running across the road. You hit that at night doing 55, not gonna be good.
Yeah. If
You
you
might
like
be able to drink standing up.
What's the dam built?
Yeah.
And more questions about this research? Then I wanted to bring up that, there's a couple things that the board has been looking at. And some of you maybe have seen some of the research by, Dr. Emily Fairfax. She's a researcher in Colorado, and she's done, research on, beaver ponds as, resilient areas in megafires. And one of the conclusions was that for each beaver pond in a megafire, it saved about 3 acres of pond and forest marsh area around the pond. So that's one thing that we're looking at, talking to Emily, Dr. Fairfax, to see how that might translate to something in northern Minnesota. And also some of us attended a Zoom presentation by the Finland area forest ranger, Ellen something, I don't remember. Anyway, she gave a great talk. You can see it on the Wolf Ridge site. But we were also looking at contacting her to see what kind of information she might have about how streams and beaver ponds fared through the whatever it was, 26,000 acre Greenwood Lake Fire. So that's some of the stuff we're working on, and hope to have some more talks and presentations in the coming year about that kind of thing, as well as keep working on all these other green forest, beaver ponds and street wildlife. Some of our best attended programs have been Emma's research, as well as roles or specific species within our water. So we'll keep working on those kinds of things. And I wanted to say, if folks if you aren't already a member, or you want to help your membership, Mark is the treasurer, and there's membership once a year. If you want to fill that out, and give Mark $20. What was the other thing? Oh, and I wanted to acknowledge, I neglected to say all the board members that have been on the board that are here tonight. Mary Furrow was on our board and was super helpful for a few years. And Dennis Polita is on Zoom, and It's been a group effort and we're super appreciative for everyone coming tonight. If you have ideas of things that you want us to look into, like research or presentations or concerns that you have, our babies are the screen for it. And if there's anything you want to know that we could maybe find something out about, bring someone in here to talk about it.
Your input would be really valuable. It's citizen group, it's so wonderful for us to be there, have a voice. More.
Super appreciate Karen and Josh and all the research. Really good.
They don't want
So much.